So last time before the spring break, you started chapter 6. Was it capital stack for part 2? Okay. And I believe you worked on order of operation, right? So tell me what you know about order of operation. What do you know? Order of operation. Anyone? Kristen.
You do the addition and subtraction first, and then multiplication and division.
Okay. Yeah. What else? Did you talk about pandas? Okay. So pandas. What is a pandas?
Parentheses, exponents.
So you start from parentheses, right? E. Pandas. So you start from parentheses. E. Exponents. Then multiplication. So do you have the multiplication always before division? Exactly. So these two, whoever comes first. So from left to right. Same for the addition. You don't do addition before subtraction always, okay? No. Whatever comes first, you can do that first, okay? So for example, if you have a question like 2 minus 5 plus 7 squared plus 3 minus 2 squared, something like that. No. This one. Multiply. How about this? What do you need to do first?
It's supposed to see it on the board.
Yeah. No wonder you look so confused. Okay, how about this? Okay, let me rewrite this. If you have a question like okay, what else you do first? Parentheses. So where's the parentheses? Right here. You need to do this operation first. 6. So you have 2 minus 6 times 7 squared plus 3 minus 2 squared. Now what? Exponents. So we have exponents here and there. You need to do the operation. So you're gonna do 49 and you have 2 squared, 4. So if we rewrite this, I can have 2 minus 6 times 49 plus 3 minus 4. Right? Now what? Do you need to subtract this first? You need to do the multiplication first. So 6 times 49, 294. And it's positive or negative? Negative because it's subtraction. So you have 2 minus 294 plus 3 minus 4. Now you have only addition and subtractions there. So what do you need to do first? Addition and subtraction? Or in that order, right? So you need to do this first because that comes before the addition. So 2 minus 294, negative 292 plus 3 minus 4. What do you get here? Negative 289 minus 4. Both are negatives. This is same as plus negative 4, negative 193. Okay, so that's the order of operation. Good job. And we're gonna move on to what is the next one? Applications. Okay, so before we do that, what's today's date? What's today? Today is Wednesday. Today is 17th, but it's also St. Patrick's Day, right? So when you guys are all going to teach in elementary or middle school, right? So one thing that I want to mention today is integrating math with some other subjects. instance, social studies. Even very young students, you can talk a lot about what's going on around the world or in the history and connect that to mathematics. Because mathematics doesn't stand alone. It's in our lives. We always have, why do we do math? Well, math is always around us. So here's one fun example that we can do. You can play this work with your students, with younger students. So let's put on our kids hat. Okay, okay. You're not 20s or 18s, 19, or okay. You're not anymore that adult. You are 7 years, 8 years, or 9 years old. 9 is too old, I think, for this one. Okay, put that hat on and solve this problem. So it's St. Patrick's Day, and we can play with pot of gold, top hat, teddy bear with a shamrock, and is that Irish flag? Okay, Irish flag, and so on. And my question is, when you are given this information, can you find out the value of all of these items together? Yes? Okay, so let's take a look at the first one. Can you figure out what each of these value? Yet? Not yet. How about here? Can you figure out what the teddy bear values? How?
Like 3 to 13 and like that.
Oh, it's very algebraic. Very algebraic. You are a smart kid. Gifted education. Okay, how about just regular kid like me? How would I solve it? I would go like, here's 3. So when you add these 2 teddy bears together, you will get 10. Then each one should be half of it, which is 5. Right? Shane, you thought the same way? Okay, we are regular kids. Okay, so I got to know teddy bear value is 5. Okay, keep that in mind. Then what can I do now? I still cannot figure these out, right? Next one down here. So we know the teddy bear value is 5, and plus Irish flag is 5 plus 4, which means flag should be 4. So we got these two, 5 and 4. Then we can solve this one, right? Since the Irish flag is 4, the pot of gold should be 9, because we know the meaning of equal sign. Equal sign means it's balancing. Both are the equal amount. Since this is 4, 4 plus 9 is same as what plus 4? You can use the commutative property, right? Okay, so this should be then 9. Now we can go back up here. If each pot of gold is 9, we have 2 pots, so that makes 18. 18 plus what makes 21? 3. So we figured this is 3, right? So we got all of these values. 9, 5, 4, 3. Add them together. What do you get? 21. So the total value should be 21. Awesome. Did you have fun? Daisy? Say yes. Okay, good. Yeah, something like this. Maybe it's not very fun, but you can find something funnier, or you can create something fun, okay, for your students. But always think about, using math in other subjects in grading them. Okay, so here are some questions using, linear equation. So I have some verbal expressions. We're gonna talk about addition in verbal expression, and we're gonna do subtraction, multiplication, and division too. So pay attention to the words, okay? So the first one, it says the sum of something. Sum of something. So we already know that this is addition situation, right? So we're gonna add some numbers. Sum of what? A number and 7. That number is not specific number, right? So we use a variable. Variable, what is a variable? A letter. Well, it can be letter, right? It's something that we don't know. So you can use, for younger students, I think you can use this blank, like a blank square or any symbol. but we use letter a lot of times because it's easier for us, right? But you don't have to use only a letter, okay? And we tend to use only X, but this number, I mean, this variable can be A, it can be star, it can be anything, question mark, whatever, okay? Just define the number is that simple. Okay, so a number and 7, the sum of a number and 7, what could go here? If we use a number with X, sum of a number and 7 should be X plus 7. There we go. How about this one? 6 more than a number. What is given to you first? 6 is given to you or a number is given to you? Take a look. 6 more than a number. Exactly. A number is given to you and you're going to add 6 more to that. Does it make sense? Okay, so you're going to start from a number and then add 6 to it. X plus 6. How about this one? 3 plus a number. It's literally 3 plus a number. 3 plus X. How about 24 added to a number? What comes first? A number was there and you're going to add 24 to it. 24 is added to a number. How about a number increased by something? A number increased by, for example, 2. Then a number is there, you are adding 2 to it, right? How about the sum of 2 numbers? You don't know those 2 numbers, you can use 2 variables like x and y, right? So x plus y. Can you build this up? Okay, go ahead. And I will give you the answer. Even if in addition the order doesn't matter because you can use the commutative property. However, I want you to pay attention to the order in this situation because this is in the context. Okay, and you need to understand the context and interpret that correctly. I will give you a minute. Okay, do you want to check? You got the same one? Any question? Increased by 3, it was 3. Does anybody have any question? Okay? Okay, how about this? In subtraction. Okay, we will do this without the answers first. 2 less than a number. 2 less than a number. What comes first? What is given to you? A number is given to you. Then you're gonna make 2 less than that, right? So starting from a number and you're gonna subtract 2. So it's gonna be x minus 2. How about 12 minus the number? It's 12 minus x, right? How about the third one? A number decreased by 3. A number decreased by 3. What comes first? A number. A number minus 3 is a number decreased by 3. How about the difference between a number and 5? A number minus 5, right? It says just a number in minus 5, but you are actually using the absolute value because you don't know whether a number is bigger or 5 is bigger. So when we're saying the difference, you're going to find the absolute value of that. For instance, what's the difference between your age and your mom's age? Well, if you subtract your mom's age from you, you're going to put the absolute value to it, right? We usually subtract smaller number from the big number. That's why how you get the positive numbers only. But you can do the other way around by putting the absolute value to it. Okay? How about a number subtracted from 10? What do you start from? 10, right? And the number is subtracted from 10. So start from 10 and subtract a number. Why does order matter in subtraction. Exactly. It doesn't work. The combinatorial property doesn't work, right? 10 minus 2 is totally different from 2 minus 10, right? So it matters a lot here. So did you get the answer for each? Can we check? You got the same answer? Check it out. You got it? Okay. How about in multiplication? 16 times a number. How about you try first? Number multiplied by 6. Think about what comes first, okay, in the context. The product of two numbers. Twice a number. 2/3 of a number. I highlighted some words there. Okay, you got it? Is it? Or was the Gabby? Alice? Kelsey?
Yeah.
Is it? How about we start from Shane? 16 times a number.
It would be 16 times that.
Everybody got the same one? Okay. Jason? A number multiplied by 6. 6 times x or x times 6. But in this case, a number comes first, right? So x times 6, but it looks weird, x times 6. So you can switch them around, that is 6x. In multiplication, it doesn't matter. You can use the combinatorial property, right? But in the context, yes, x times 6. How about the product of two numbers?
X times y.
X times y. The product is the answer of multiplication, right? Okay, let's go back to addition and subtraction quickly. So we use the product in multiplication as the answer. What was the answer for subtraction? No? The difference. How about in addition? The sum. The sum, the difference, the product, and in division it will be the quotient. Okay, we'll talk about that. Okay, anyways, the product of two numbers, if you see that it's a product of two numbers, you can multiply them together. Kelsey, twice the number. It says, no, twice means it's 2 times. So double of something. So 2 times.
Oh, okay.
Okay, awesome. 2 times x, right? 2 times x. How about the last one, Gavin? 2/3 of a number.
Would it be x times 2?
Yeah, you can do that way because you can use the combinatorial property, but using just the context, you can just say 2/3 of means times a number x. 2/3 x. Okay? Right. So check these answers with yours. Any question? Okay. So let's look at the division. We have much shorter list here. Here, the quotient of 8 in a number. In division, just like subtraction, the order matters because 6 divided by 2 is totally different from 2 divided by 6, right? Okay. So what comes first matters. Think about it. Quotient of 8 in a number divided by 13, the ratio of two numbers, and the quotient of two numbers. Okay, oops. Okay. Let's take a look at the first one, the quotient of 8 and a number. What did you write? A quotient of 8 and a number. 8 divided by a number. X. We don't know the number, right? How about the second one? A number divided by 13. So x divided by 13. How about the last one? The ratio of two numbers. If we are writing ratio, we usually write x to y, don't we? And we can also write this into fraction. So x over y. X over y, right? This means x divided by y, right? So this is the same as quotient of two numbers of x, y. The quotient is the answer of the division. So this is exactly the same meaning. That's why I say here the ratio of two numbers or the quotient of two numbers. Okay? All right. Any question for that? Okay, I think you guys got that idea. So we're gonna do some examples here. But when you are solving a word problem, you need to read the problem carefully, at least twice to be sure that you understand that. If possible, draw a sketch to help visualize the problem. Drawing sketch really helps me to understand what's going on there. Especially the younger students, I think it really helps. You don't have to draw, perfectly. It's not an art class, right? You can simplify that. But when you're drawing the situation, it really helps. Third, determine which quantity you are being asked to find. Again, sharing the screen. Okay. Determine which quantity you are being asked to find. Choose a letter to represent this unknown quantity. Write down exactly what this letter represents. So if you are defining the value as x, you need to define what x is. Okay. Number 4, write the word problem as an equation. Then solve the equation for the unknown quantity and answer the question or questions asked. Then make sure to check your solution. Okay, this is the steps to follow. So here is one first example that you are going to solve. Okay, I can randomly call your name to solve this problem. Jaina purchased a copier for $2,300 and 1 year maintenance protection plan that cost 2 cents per copy made. If Jaina spends a total of $2,626 in a year, which includes the cost of a copier and the copies made, determine the number of copies she made. So we are given enough information to solve this problem. So she purchased a copier, paying $2,300. Then she paid $2,300, and she also has to pay 2 cents per copy. And this year, she paid $2,626, including the copier and the copies, right? What you need to determine is how many copies she made. Read it carefully and write an equation using this information. This is correct calculation, but can you write an equation? Can you write an equation? Oh, just interpreting the situation. So yeah, I will show you how to do that first, okay? Since this is the first problem, you guys just write into finding the answer. That's okay, but I want you to have some habit of writing an equation. So I will show you how to do that first, okay? Next problem, you can set up an equation. So let's interpret what's going on here. Okay, so Jana purchased copier for 2,300. That's how much she spent first, right? That's the copier. And she also needs to pay 2 cents per copy. So if she print out only one copy, she's gonna pay 2 cents, right? If she has 2 copies, you want to multiply this by 2, that's how much she's gonna spend, right? So we don't know how many copies, but that many copies will cost 0.02 times x much, right? So what did I say about the x? I can define this as number of copies. You need to make sure what your variable stands for, right? So this is how much it costs when you make copies. This is how much you pay for the copier. This is how much you pay for the copies. Together, she pays 2,626. So this is the equation you are setting up. Okay? Now you can do the work here to solve for x using this information. We are solving for x because that's the number of copies we are looking for. So what do we do first? We can subtract 2,300 on both sides, right? Then you get 0.02x is equal to, by subtracting 2,300 on both sides, this is gone, and you have what? 326. Yeah? And then what do? We can divide both by 0.02. Divided by 0.02. And x is? What's divided by 0.02?
16,000.
It's the same as multiplying by. Yeah. So what is it?
16,000.
16,300? That's how many copies you made. If you have a calculator, you can just do, divide it by 0.02 easily. But to me, I don't have a calculator. Let's suppose that I don't have it, and it doesn't look easy for me. So what I'm gonna do is calculating differently using fraction. What's 0.02 in fraction? 200. This is called 200, right? So 200 times x is 326. 200 is simplified as 1/50, right? So it's 1/50 times x is equal to 326. So if I multiply 50 on both sides, I can simplify this. So x is 326 times 50, and you get 16,300. Okay? So either way, it works. Does it make sense, guys? Okay, let's do one more. Here. How do we read this Roman numeral 4? Because this B stands for 5. 1 before 5 is 4. So we read this as 4. Mark IV Construction Company purchased 100 acres of land to be split into 3 parcels of land on which to build houses. One parcel of land will be 3 times as large as each of the other 2. Oh, so they didn't make 3 equal parts, right? But they made different parcels. So maybe drawing pictures can help? What do you think? To me, it does. So let's think about drawing simple picture. So this construction company purchased 100 acres of land. So let's suppose this is 100 acres. of land to be split into 3 parcels of land. One parcel will be 3 times as large as each of the other 2. So each of the other 2 are equal, right? So I can say that, oh, this is x and the other one is x, but the third one here, that is what? 3 times as large as each. So this is 3 times as large as one of them, right? So can I write it this way? So when I add all these together, it should be 100 acres. So what kind of equation can I write it here? 3x plus x is what? 400. 3x plus x is what? How many x's? 5 x's. 3, 1, 1. So that makes 5. 5x is equal to 100. And x is divided by 5. So you get x is equal to 20. So this tiny parcel is 20 acres. And this is also 20 acres. And the third one is how many acres? 60 acres. Okay, when x is one small parcel. Small parcel in acres. Okay? Alright, so something like this problem, maybe drawing picture will be helpful. Okay, let's look at the next problem. For this one. Javier is building a rectangular sandbox for his children. He has 34 feet of wood to use for the perimeter of the sandbox. What does the perimeter mean?
All the way around.
All the way around, the length around the shape, right? So perimeter, the etymology of perimeter is a peri plus meter. Peri means around, meter means measurement. So length around that shape is the perimeter, okay? So you want to use 34 feet of wood to use for the perimeter of the sandbox. In this question, maybe it's easy to draw a picture too, just like this. What should be the dimensions of the sandbox if he wants the length to be 3 feet longer than the width? If we say the width is W, the length should be 3 more to that, x plus 3. For this question, I put W instead of x because W can stand for width. The length should be width plus 3, right? You don't have to draw beautiful picture like this. You can just make a rectangular shape to represent the box, right? You can simplify the shape too. So what equation can you set up? Damn it. What did you write?
So would it be like, would the W plus 3 be in parentheses plus another W?
Keep going.
Equals 34 feet.
34. So let's see. How do we get 34? 34 is the perimeter. Perimeter means you have length plus width plus length plus width, right? So we have 2 length and 2 width, right? But our length is 3 feet greater than the width. So you can just substitute the length with what? W plus 3. And you still have the 2W. So I just substituted L with W plus 3, where L is the length and W is the width. So you need to define what your variables are. Without defining the variables, you cannot just solve it. Okay, so make sure you define what your letters are. So now we have only one variable with one equation. With one equation, one variable, you can solve for that variable, right? So this is what? 2 times W plus 3, you can distribute 2 to each of the terms. 2 times W is 2W. 2 times 3 is 6 plus 2W. So what W? 2W plus 2W, 4W plus 6 is 34. On the left hand side, I always have 34, right? So now what? JC, now what do I do?
You're gonna subtract, you're gonna get rid of the 6 on both sides, so you're gonna subtract 6, get rid of it on that side.
Okay, and you get
You
30?
get
No, 28.
28.
Thank you.
And then you take 28 divided by 4 to get your answer.
Awesome. Thank you. So width is given, right? We found the width. Not given. We just found the width. How do we find the length? The length is W plus 3, right? So length is W plus 3. Because length is 3 feet greater than the width. So length is 10 feet. Right? That's the unit. Thank you. Oh, we found them. That's the dimensions. Are we good? Okay. I think you're getting there. What do you think? Yes? Okay. How about this one? Female selling her homemade jewelry determine the cost of a necklace before tax. If the total cost of a necklace, including an 8% sales tax, is $34.56. So you need to put a variable x as what? The cost of the necklace before tax, right? Let's define x as the cost of a necklace before tax. Now what? What are we given? The total cost, including the tax, is given, right? So $34.56 is, you are adding the total cost and its tax, right? So the cost of the necklace before tax plus the tax. How do you calculate the tax? It's 8% of how much ever you're asking for, right? So 8% is 0.08 of that necklace cost. You can set up an equation this way. Are we good? Okay. So 1x plus 0.08x is what? 1 plus 0.08. 1.08x is 34.56. How do we find x? Again, divide both by 1.08. So it's multiplied. And what do you get? Does anybody have a calculator? It's 34.56 divided by 1.08. How see? 32? Thank you. So the original cost is $32. How can we check this? Well, you can just calculate it, right? So to check, let's suppose your necklace before the tax is $32 and you are paying 0.08, so 8% of $32. And how much do you get? Yes, you get 34.56. Then it is correct answer. Okay? Awesome. You can also use your number sense too. your original price is $32 and your necklace cost after the tax is $34.56, it makes sense, right? It's smaller than the after the tax, so it makes sense. Then you can use your number sense to check the answer as well. All right, so let's look at the proportion. I briefly talked about the ratio in the quotient, right? Remember ratio, quotient. So ratio is a quotient of two quantities. For example, 2 to 5, you can write it 2 to 5 or 2 to 5 using this symbol, or the same as 2 over 5, right? So when you're writing rational number, are you familiar with a rational number? Rational numbers are the numbers that you can write into a fraction. Okay, so if you can write a number as a fraction, it's called a rational number because you can make the ratio. Okay. How about the proportion then? Proportion and ratio, people confuse them a lot of times, but they're not exactly the same. What's the difference between ratio and proportion? So ratio is just, between two numbers, relationship between the two numbers. But the proportion is a statement. So there's an equation to it using the ratio. Okay? So to solve a problem, you gotta use a proportion because it's an equation. Okay? Okay, so for example, like this. If you don't have right hand side part with equal sign, it's just a ratio. So you are using two ratio to set up an equation, then it becomes a proportion. For example, we are given, let's say, a ratio of width and length of that crayon. Let's say that's 4 to 5. I'm gonna shrink it with the same ratio. You're gonna say that it's still 4 to 5, but the length is not 4 feet and 5 feet anymore, right? It can be smaller size, but the ratio is still the same. That is a proportion, okay? Right. So for instance, to solve this problem, I will just show you how to solve this problem. You are given x plus 2 over 5 is the same ratio as x plus 5 over 8. You can see these two fractions with different denominators. So usually we find the same denominator using the least common multiple, don't we? So what's the least common multiple of 5 and 8? 40. You can change these both to 40s. What I'm saying here is this. This is a little bit different from what I wrote there, okay, but it's the same concept. So a lot of us and our students are familiar with finding the common multiple, common denominator. So we know 40 is the common denominator, 40 and 40. Do you agree? So how did I find a common denominator here? By finding the least common multiple. How did I change 5 to 40? I multiply this by 8. So you're going to do the same thing here. Multiply that by 8. How come these are equivalent? Because look, what did I multiply? 8 over 8. What's 8 over 8? 1. When you're multiplying by 1, you get yourself. What kind of property is that? Multiplicative identity property, right? So when you're multiplying by 1, you get yourself. So even if I change the denominator 5 to 40, it's still the same thing if I multiply the numerator by 8 as well. Okay? So I get x plus 2 times 8, or you can distribute 8 to each of these terms and get 8x plus 16, right? Do the same thing here. What did I multiply here? 1. So 1 is the same as 5 over 5, right? So 5 times 8 is 40, 5 times x is 5x, 5 times 5 is 25. Since I have the same denominator in the equation, I can just look at the numerator, compare them. So I have 8x plus 16 is equal to 5x plus 25. You see that? And now you can combine like terms. The x term is here, x term is here. You can combine them together, and the constant here and constant here, you can combine them together. So I can subtract 16 on both sides, right? So this is gone, and I can subtract 5x on both sides. And this is gone. What do we have on the left hand side? 3x. Right hand side, 9. And divide both by 3. So x is 3. You can solve it that way, okay, using the proportion. That's exactly same as this one I have, but I didn't change this to the common denominator. What did I do? I multiplied the common denominator, didn't I? That's because I can just multiply 40 in the common denominator and cancel that out. So the procedure next to it is exactly the same. Okay, so you can choose either one. In proportion, you can also do the cross multiplication. Are you familiar with it? Cross multiplication, you can just do A times B equals B times C. Okay? So you can just multiply these together and that together, they are equal. Okay, so let's just finish this one today. Okay, hold on. Using this, you can solve the rest of the problems. So I will not solve the examples. But when you are doing this one, 8 times x plus 2 is equal to 5 times x plus 5. You see that, right? What you need to be careful is you need to distribute 8 to each of the term and 5 to each of the term as well. Then you can follow through. Any question? Okay, so you are able to solve the problem. Same for this one. Okay. I will open the question for homework, and it's due by Friday. But I'm gonna record, this solution of examples and send you guys an email about that. So if you are confused with any examples, please let me know and please watch the video. Okay. All right, and I will see you guys on Friday, and we'll move on to next section.